Hi my dear students, Assalamu alaikum to all. Once again I warmly welcome to all in my class. Okay, what's our chapter name? Yes, our chapter name is Forces in Fluids. Forces in Fluids. Yes. Have we learned what we taken in the last class? Yes, in the last class we learned that the Archimedes principle. What is the Archimedes principle? So, what is Archimedes principle? Do you remember what is Archimedes principle? Yes, when an object is immersed completely or partially in a fluid, the buoyancy experienced by it will be equal to the weight of fluid displaced by it. Yes, what is Archimedes principle? Yes, when an object is immersed completely or partially in a fluid, the buoyancy experienced by it will be equal to the weight of fluid displaced by it. Okay. Next, let's do an activity. Yes. So, what is this? Do you know what is this? Yes, it is an aluminium foil. It is an aluminium foil paper. Okay. So, now I am going to make a vessel using this aluminium foil. Yes, I make a vessel using this aluminium foil. Okay, then I put this. So, make small vessel. Yes, then I place this in this water. What do you observe? What do you observe? Is it sink? No, it doesn't sink. Then I take this aluminium foil paper and I folded into becomes, I folded it. I folded it to become small piece. I folded it to become small piece. Then I put this onto this water. What do you observe? Yes, it sinks in the water. It sinks in the water. When I take aluminium foil paper and make vessel and place this water, that time it floats. Then I folded it becomes a small piece. Then put this water. What do you observe? Yes, it sinks in the water. Yes, in this two times when I place take as a this vessel and was there in the form of folded piece. Was there any change in its mass or weight? Was there any change in its mass or weight? No, there is no change in mass or weight. Then why this folded foil sink in this water? Why? Why? Yes, what is the reason? Do you think about that? Yes, in that time, in folded piece, the folded type, there is no change in its mass, but its volume decreases. Its volume decreases. So, we know that density is equal to mass by volume. Density is equal to mass by volume. So, here we said that when folded piece, that time volume decreases. Volume decreases. In that time, density increases because density is inversely proportional to volume. When volume decreases, density increases. So, the folded paper sinks in the water by density increasing, by the increasing of density. Are you understand? Yes. To understand the small, let's do another experiment. Okay. So, what is this? Yes, this is a wooden block and this is a stone. Wooden block and stone. Then I place this wooden block and stone into this water. What do you see? Yes, the stone sinks in the water. Its stone sinks in the water and wooden block floats on water. Stone sinks in the water and wooden block floats on water. What is the reason? Yes, we can find out the reason of this. So, we want to find out the buoyancy and weight of water displaced by it. Okay, we want to find out buoyancy and weight of water displaced by it. So, here we take body. Which bodies? Yes, first wood, then stone. First we want to find out weight in air. Weight in air. Then weight in water. Then buoyancy. Then weight of water displaced. Yes, we take wood and stones. First we want to find out weight in air, then weight in water, buoyancy, weight of water displaced. So, first I take a wood, a piece of wood. I take about 5 Newton. 5 Newton wood. So, what is the weight in air? That is 5 Newton. Weight in air is equal to 5 Newton. Then I put this wood into the water. Then what will be the weight? Yes, we know that it floats on water, then its weight is 0. Then how to find out buoyancy? Yes, we know that buoyancy is equal to weight in air minus weight in water. So, 5 minus 0, what? 5 minus 0, 5. Yes, 5 minus 0, 5. Then I put this wood into, what is this? Overflowing jar. Overflowing jar. Then I place this wood piece into this overflowing jar. That time water flows and collect this another jar. Collect this water into another jar. Then after finding weight of water displaced, what will we get? Yes, we get 5 Newton. We will get 5 Newton. Next I take stone. Stone about 7 Newton. I take stone about 7 Newton, big stone. So 7 Newton. So weight in air 7 Newton. Weight in water, after measure the weight of stone in the water, we will get 5 Newton. Yes, 5 Newton. Then buoyancy. Buoyancy what? 7 minus 5. 7 minus 5. Yes, how can we find out 7 minus 5? We know that buoyancy is equal to weight in air minus weight in water. So, 7 minus 5, 2 Newton. 2 Newton. Like that stone also, place this in this water. That time water overflow to another jar. Then measure the weight of the water. That time we will get, measure the weight of water, we will get 2 Newton. 2 Newton. Yes. Do you see this? Yes. In wood, weight in air 5 Newton, weight in water 0, buoyancy 5 Newton and weight of water displaced 5 Newton. In stone, weight in air 7 Newton, weight in water 5 Newton. Yes, then buoyancy 2 Newton, weight of water displaced 2 Newton. Yes, analyze the table. What do you understand? Yes, in wood, weight in air is equal to buoyancy is equal to weight of water displaced. But in stone, weight in air is not equal to buoyancy, but buoyancy is equal to weight of water displaced. So, how can we find out is it float or is it sink? Yes, if we take a stone and to this water, if we place the stone, yes, weight of stone is more than weight of buoyancy. It is weight of stone and it is buoyant force. Yes, weight of stone. Here we can understand that weight of stone is more than buoyancy. Weight of stone is more than buoyancy. We know that weight is acts downward, buoyant force acts upward. So, it is tendency to sink. That's why stone sinks in the water. Okay, that's why stone sinks in the water, because weight of stone is more than buoyant force. That time it is sink. It will sink. Next, if we take wood, you know that yes, weight in air is equal to buoyancy. Weight in air is equal to buoyancy. Weight of wood is equal to buoyancy. That time weight, we know that weight acts downwards and buoyant force acts upwards. So, it floats on the water. Weight of object is equal to buoyant force. It floats on the water. Okay. Yes, we can understand these things from this table. Then, what is another situation for wood floats on water? What is another situation? Yes, what is another situation for wood floats on water? Yes, weight of object in air is equal to weight of water displaced. Weight of object in air is equal to weight of liquid displaced. This is the principle of flotation. So, what is the principle of flotation? Weight of floating body is equal to the weight of the fluid displaced by it. Weight of floating body is equal to the weight of the fluid displaced by it. Yes, when a body is fully immersed in a fluid, the volume of displaced fluid will be equal to the volume of object. Okay, volume of that body. So, what is the principle of flotation? Weight of floating body is equal to the weight of fluid displaced by it. It is the principle of flotation. Weight of floating body is equal to the weight of fluid displaced by it. Then, when a body is immersed, completely immersed in a fluid, the volume of displaced fluid will be equal to the volume of the object. Okay. So, next you have a homework in page 13. You can see that identify the reasons for the following based on what you have learnt. Yes, first reason, a piece of stone experiences a loss of weight while inside water. Yes, what is the reason that you write there? Then second one, Though an egg sinks in pure water, it will float on salt water. That is second question. Then third question, kerosene floats on water. Kerosene floats on water. Then fourth, a ship floats on water. A ship floats on water. You all of you write the reasons of these things. Okay. The last, when a body was placed in a liquid, it remained in the same position. Okay. All of you write the reasons of these things. Okay. This is the homework for you. Yes. Yes. What have you taken in today? Yes. Today we take the principle of flotation. The principle of flotation. What is the principle of flotation? Yes. The principle of flotation. The weight of floating body is equal to the weight of fluid displaced by it. Weight of floating body is equal to the weight of fluid displaced by it. When a body is immersed completely in a fluid, the volume of displaced fluid will be equal to the volume of that object. Okay. All of you read this, study well. Okay. Thank you. Let's wind up today's class. Okay.